Yeah.
I'm ready ค่ะ
Okay, you can go.
My term project is about.
Do you hear the sound โอเคค่ะ
Okay, go ahead, go.
Good afternoon ค่ะ My name is Nathamon and my project is diabetes prediction.
Diabetes prediction by using machine learning, Python, and support vector machine. This mind map contains the overall data that I have used for this project. I divided the table of content into 7 topics, starting with the introduction to project, data collection and analysis, data standardization, trend test split, model evaluation, and predictive system. And now begin with the introduction to project. With the use of machine learning, I'm developing a system that can predict whether or not a person has diabetes. Python is used to complete this project, and for the prediction in this project, I use a support vector machine model. In machine learning, support vector machines are supervised learning model with associated learning algorithm that analyze data for classification and regression analysis. I feed the data to my machine learning model, and the machine learning model learns from the data and its respective label, which means that the label are the most important things. Therefore, I train my model with several medical information such as the BMI of the patient, the blood glucose level, the insulin level, and the level of patient, along with the whether the person has diabetes or not. So this acts as label whether the person is diabetic or non-diabetic. And once I feed this data to my support vector machine, it tries to plot the data in a graph, and once the data is plotted, it tries to find a hydroplane. So in this image, you can see the hydroplane which it is separating these two data. And once I feed a new data into this model, it tries to put that particular data in either of these two groups, and by that it can predict that the person will be diabetic or non-diabetic. And how can you tell if you have diabetes or not? Mostly symptoms are from higher than normal level of glucose, a kind of sugar in your blood. The warning sign can be so mild that you don't notice them. That's especially true for type 2 diabetes. Some people don't find out they have it until they get a problem from long-term damage caused by the disease. With type 1 diabetes, the symptoms usually happen quickly in a matter of days or a few weeks. They're much more severe too. I use the diabetes dataset from the National Institute of Diabetes and Digestive and Kidney Diseases. The objective is to predict based on diagnosed measurement whether a patient had diabetes. From the source of Kaggle and all patients here are female at least 21 years old of primary Indian heritage. The first step is to import the dependency. NumPy is used to make the NumPy arrays. Pandas is mainly used for creating data frames. Standard scalar is used to standardize the data. Trend test split is used to split the data into training the data, and then import the support vector machine and accuracy score. And for the data collection and analysis of the primary diabetes dataset, there are 768 rows and 9 columns. And 768 rows are the example that means the data is taken from 768 people, and the 9 columns represent the features or the parameter or attributes. So these are the medical information that I am going to use for the prediction. This describe function provides the various statistical measures such as the mean, standard deviation of the data, percentage minimum and maximum value of the 8 columns. Now, let's see how many cases are diabetic example and non-diabetic example. This function is to find the mean for both cases, so it calculates these values for all the data set. I found that there was a difference in the glucose level, so basically the glucose level is more for the patient with diabetes, and age is also more for the people who have diabetes. So I will say it is one of the important insights that I get from this data. Then I splitted the data and the label separately, taking the variable x and dropping a particular column outcome, and the x is equal to 1. Then storing those or the label in this variable y. And the next step is data standardization. in order to make the data in a particular range for machine learning to make a better prediction. And then filling all this inconsistent data with the standard scalar function based on the standardization, then transforming all the data into a common range. So X is the standardized data and Y is the label which is the PD dataset outcome. When it comes to train test split, this process is to split the data into training and testing data. Y train represent all the label for this X train data. Y test represent all the label which is 1 or 0, which represent diabetic or non-diabetic for this X test data. And the train test split function will give the full outputs. Once the code is run, it can be seen that there are totally 768 examples in the original dataset, and out of those, 614 are used for training data and 514 will be the test data. This is a good proportion where I took only 20% of the data's test data. And for the SVC is the support vector classifier. And as you can see, the X train and Y train at the bottom represent the training data and the label of training data. The model evaluation is used to find the accuracy score of the model. So if you tell how well the model is performing, once I obtain the model, I have found the accuracy score on both the training data and the test data by using accuracy score function. And the results show 0.78 for the training data and 0.77 for the test data. Since the accuracy of these data are pretty good because they are all above 75, so it is good for the predictive system in the next step. Once I have a good accuracy score, I made a predictive system that can predict whether a person has diabetes or not with the help of this input data. And the first step of the predictive system is to change the input data to NumPy array. And then we shade the array as we are predicting for one instance. And 1 and minus 1 is the parameter for this reshaping. So this will tell the model that we are not giving 768 examples, but just trying to predict the label for only one instance. And then standardize the input data, prediction, and find the result with the number 1. The person is diabetic, as you can see from the example here.
It's done ค่ะ
Okay, very good. It's a standard flow of a prediction model. Having said that, I think you mix up one step. The standardization is to make sure that you have a sort of like a proper scaling vis-a-vis variables so that one doesn't dominate the other. Okay, now that's good. That's what you should do. Having said that, you only know the mean and standard deviation of your in-sample. So if you actually standardize the whole data, including the test set, you're cheating a little bit, right? Now, in most applications, it really doesn't really matter, but I just want you to practice the right discipline, okay? So if you use a standardizer as a built-in function from scikit-learn or whatever, right? And you apply it to the standardization vis-a-vis the whole data set, what it's going to do is going to take the mean of the whole data set, okay? And the standard deviation of the whole data set. You don't want to do that. You want to take just the mean and standard deviation of the training or the in-sample set in this case. There's no validation test, okay? Then when you apply it, you will notice that if you apply to the if you apply to everybody, to the in-sample as well as out-sample, you can still measure the mean and standard deviation of the out-sample. You will realize that it's not exactly 1 and 0 or 0 and 1. Okay, there'll be a little bit of shift, and this is also part of your reporting. Okay, you have to report that, yeah, there's a little bit of a mean shift, there's a little bit of standard deviation change with respect to the testing versus in-sample. Okay, so what you would do is either run what's called a standardizer for the in-sample, save that as a function, then apply it to out-sample, Or just very easily, you can just calculate the in-sample mean and in-sample standard deviation and use that to subtract and divide the whole set. Okay, that's point number one. Point number two, and I'm not going to tell you the answer, is you're basing your analysis on accuracy. Accuracy is a good number, right? But remember, one of the disciplines I told you to think about is the trade-off between different kind of falseness, false positive, false negative, and so forth, right? In particular, for binary classification, it's a trade-off between precision and recall. Okay, you have to answer yourself for your problem in diabetes. I'm not going to answer the answer right now. What is more important to you? Okay, precision or recall? Okay, I think I kind of answered that already in another example. I think with respect to cancer or something. But I want you to thoroughly think about it. Okay, so those are the two correction you have to put in. Put a little bit of reference as to support vector machine. Again, I personally am not a big fan of support vector machine because it's linear until you know what the kernel is, and if you knew what the kernel is, then you can just transform it. So I'm not that big fan of support vector machine, but you can certainly reference some literature of why this has been successful in this kind of problem. Okay, so in your final report to reference that. Okay,ครับ very good.
I got it. Thank you ค่ะ
ครับผมโอเคครับ next up confirm your name as well because I just want to make sure I have the right sequence.
It's me ค่ะอาจารย์
Okay ครับ
Okay.
Okay, can you see this?
ครับ who are you คะ you
Can you see the screen and me?
She's
okay
shingling me.
shingling. Oh, how come I don't have shingling now? Wait a minute.
Okay.
My bad.
Oh my god. Can you hear that?
Okay, so it's shingling up first, right? Okay.
Yeah.
Okay. Let me.
My name is Shilin Lee, and I'll be presenting the analysis of a chess game data set. I'll be demonstrating data analysis of quantitative data using statistical methods. The data is measurements and records of a series of chess games in a form of nominal, interval, and ratio scale. The problem is formed with available resources using preparation of harvesting, storing, cleaning, and curating from Kaggle. Descriptive statistics using data visualization, such as visualizing compositions and statistical measures with statistical moments, such as central tendency and empirical measures. Next, statistical measures are mainly probabilities model of univariate and sampling distribution. There will also be machine learning with supervision using prediction methods. Chess has always been attracted by researchers, data scientists, or even chess players like me, even as a beginner. And with this, it is undeniable how there are already many available online chess game analysis. Although my goal differs in not how I will be finding competitive tasks advantageous, but on how I will also be analyzing commonly used moves and finding whether there are any relationships between each individual factor, such as the opening moves and the winning color. The time of this game data set is from my own personal interest and hobby on chess. My goals are statistical moments and empirical measures of each individual factors, probability of games won by white, black, and higher ratings, most common and whether there are any correlations between winners and openings, opening moves, ratings, colors, and turns. So the data is based on CSV categorical file-based data sets retrieved from Kaggle, selected from an online chess game website called Lichess, which includes interval skills such as the game ID, ratio skills such as the ratings, and nominal skills such as the winner chess colors. So I imported the file of 20,059 rows and 17 columns, and a table form shows a different list of dataset topics. So as mentioned, my approach is to demonstrate visualization tools and statistical analysis with supervised machine learning methods using the help of Wolfram Mathematica and Jupyter Notebook document. So experiments. Winning color. After importing, calculating, and plotting the amount of times won by each color on the pie chart, the percentage of white winning is nearly 50% and black around 45%. In other words, white players have a higher probability of winning chess games. Next, the opening moves. It is found that there are an overall of 128 different types used, and the most common one is the Sicilian defense. Next, the amount of turns per game. The most common turn range after sorting and counting as well as using the key function is 53 times. Next, the amount of opening moves. The most common amount of opening move range is 3 moves. Next, white ratings. The most common white ratings is 1,500. Next, black ratings are very similar, where the most common black rating is also 1,500. If compared to 2, the bar chart shows clearly that if white ratings are more than black ratings, the win rate for white players is higher than 50%. Next, between opening moves and winning color, the most successful opening move is Sicilian defense. On the other hand, there are 38 least successful opening moves that leads to winning. The most frequently resulting white scores winning color is actually black, where the most white color rating scores that win is around the score range of 1,400 to 1,700. Similarly, the frequent black color rating score that actually win is around the score range of 1,400 to 1,500. From above, the percentage of white winning is 60% and the percentage of black winning is only 40%. As for the number of turns and winning colors, the most common turns used are 53 for white and 52 for blacks. And lastly, for the number of opening moves and winning colors, the most commonly openly moves are 4 for white and 3 for black. And this is some attempt on measurement object of the predictors. So the key important findings are white player has a higher percentage of winning chess games. The opening move silicon defense is mostly the most common use and the most successful opening moves. And the most frequent white color rating scores that win is between 1,400 to 1,700 and black is between 1,400 to 1,500. So to conclude, I would like to continue analyzing more key insights, especially using more supervised machine learning techniques, and hope others can carry on their research as well. So bibliography, lastly, this is the link that is used. Thank you.
Okay.
Okay, that's very good. I think your output is more on the visualization. In which case, I think in your write-up, you have to do a little bit of a background work in terms of laying out the application perspective a little bit. You know, for example, if I wanted to, let's say I'm interested in your paper, that would mean that, you know, I'm kind of like trying to get a good idea of not just a prediction or percentage or ratio of how many times white wins as opposed to black. That's sort of like a straightforward average, right? But something like a strategy. So how you tie in with a strategy. So maybe you have to give it a little bit of a background as to how chess has become, what you call chess opening tend to follow patterns. All right, chess opening tend to follow patterns. And how much of it is a matter of choice of the players to use this kind of, you know, Sicilian opening or whatever, Queen's Gambit or whatever. Okay, so there maybe you can spend a little bit more time in your introduction section as to what are the variability you can expect of a chess game. Okay, so is it just you know, you have 5 opening moves you can choose, and the other one have 5 counter moves you can make, and just a combination of that, or is there something more to it? Is there room for innovation? What if the opening moves have not been cataloged? In other words, it's not one of the classical defined set of opening move, or is that not possible at all nowadays because every sensible opening has already been cataloged in the, you know, last 500 years or something like that. In this case, so we're trying to build a narrative why your visualization is important, right? Otherwise, if you get to just on average, you know, 5 blacks versus white, or how many turns per game, what does that mean? What does that mean? Does that mean that as a spectator, once it gets to 63 turn, I should, you know, get really excited because this game is something out of ordinary? What would the visual? In other words, you're going to be showing the visualization, so you have to sort of like build up the expectation of why it would be exciting to discover something. Okay, is it a big deal to find out that blacks and whites don't win at 50-50%? Is that the sort of like conventional folklore and say you must have 50%. So if white wins more than 50%, it's a big deal. It's a big discovery. It's a big excitement. Well, I don't know. I'm not in the world chess. So you have to basically make your thing exciting in a sense, right? Now, getting to the prediction, I guess that's not really the strong part of this, but maybe you can play more with it, or sort of like suggest that in a more like a conclusion, like future work or something. Okay, but yours is more on the visualization of the history. Okay, basically, the word histogram came from the word history. So looking at history numerically, that's essentially your project. Okay, so try to make that exciting. Okay, very good. Okay, who's up?
Me.
Who's me?
นายพักค่ะ
Mundi, right?
Yeah,
right?
let me share my
Okay,
screen.
okay.
Can you see my screen?
Come on, go ahead.
Okay, let me start then. Hello guys, my name is Class15a and this is my final project presentation on Big Data and Analytics presenting Ajahn Phumjai Nakasu. So my slides will be based on 5 major headings: introduction, including introduction, data, methods, results, and mind map. The first one, introduction, what is my project overview and what is the problem root? So since the e-commerce logistics have become more challenging in recent years, while big data also plays a big role in e-commerce logistics, big data can help identify demand patterns and trends that were previously invisible. And it also plays a vital role in optimizing product transit by making real-time data analytics possible. So my objective of the project would be to know more about customer behavior, to interpret customer by providing valuable insights, and to examine factors that may have an effect on specific data column. So let's move on to our second agenda, the data. Where is my data come from? The content of the data set. My data set contains around 11K observation or 12 variables, aka 12 columns of data, which is like ID, warehouse block, mode of shipment, customer care calls, customer rating, cost of the product, prior purchases, product importance, gender, discount offer, weight in grams, and return time or not. And of course, my data source comes from kaggle.com, and I'll be using all columns of my data. And this is my example of data set. I'll divide it into 4 different types of data: nominal, ordinal, interval, and ratio. Let's move on to the third one, methods. So why am I using a supervised learning? These are 6 main libraries using in Python: Pandas, Matplotlib, NumPy, Seaborn, Plotly, and Scikit-learn. And the first step of my data visualization project would be the import libraries, loading data set, data cleaning, and the fourth one would be data visualization, which will be shown in the results and demonstrations of our fourth agenda. Okay, let's see what is supervised learning first. The word supervised comes from the fact that the target output value is already defined and part of the training data. There are 2 things of the supervised learning. It would be classification and regression. Classification divides data set into classes, and regression is used to output continuous values. And this is my example of visualizing only one set of data set, the heat map of X sets. And here we come, the very, very interesting histogram. Having 2 sets of data sets, cost of product and warehouse block, this histogram shows that color rate or block F has obviously the most product stored in warehouse. The cost of product would be around $250 to $274, a more number. And the second histogram shows that the color rate or ship mode from the mode of shipment is mostly chosen for any cost of product. And the third one, this histogram shows that there are two mainly modes for product importance, low and high. Most of the products are low importance if it's in very, very super high cost or super low cost, which shows that even in the high cost, the product importance can still appear to be low. The histogram, this one, from the gender and the cost product shows that the red color in male, the blue color of female appear to have no much difference in buying what cost of product. Okay, so this histogram shows that there are most likely that products will be shipped on time, regardless the mode of shipment. And this is a histogram plot, shows both number of data set and parabola graph, displaying ratio and interval of the data set. Also, it shows that number 3 and 4 are most likely the frequent calls of customer categories. So these are the scatter plots. The left one is the first one, shows that one, not on time, highly have to offer discount to customer than 0 or on time. Yeah, it's obviously true, right? And the second scatter plot on the right hand side shows that 1 or not on time likely come from heavyweight products than 0. And this is our my map. Okay, thank you. Bye-bye.
Okay, almost very exciting. In the sense that I think that the scope that you started with, the idea that you're going to help with logistics, and logistics is usually viewed as an optimization problem. Okay, it's viewed as an optimization problem, meaning you have all your shipments requirement, you have all your capacity constraints, you have all your cost matrix put down, and it's a matter of making the planning so that you minimize the overall cost or the time of arrival over there. So the idea that you will add data insights to logistic problems is quite exciting. Now, then you jump straight. I think you're missing the proper problem formulation slide, right? You jump straight from saying, this is the motivation for what you want to do, immediately to whatever the data you have. So what exactly do you want? Okay, I think you can be more precise in your objective. Okay, so you want to what? You want to identify patterns of where the shipping costs are concentrated, and therefore provide this as insight for engineers or product or logistic planners to perform optimization downline. Or are you actually going to be able to make suggestions for cost reduction immediately available from your analysis? So be a little bit more precise, okay? It's good that you're bridging data science into logistics, but as with anything that's worth doing, you have to be more, you have to have a good mind map. In this case, not about the pink one, but the mind map about your own approach. Okay, so you say, well, there's a problem with logistics that has maybe too high a cost with respect to certain shipping modes, and you're trying to identify that, or you're trying to, I think there's a lot you can do. I mean, this could be a very exciting project if done right. Okay, right now, even you're discovering something, at least, the fact that the rating or importance of product is bimodal, maybe that is interesting. Maybe that's already a common knowledge, right? Because people either say, this is urgent, it has to get there right away without delay, or whatever, just shipping a pair of shoes or something. So try to spend a bit more time on your problem formulation, make it more precise. Okay, you're translating this into this visualization exercise, or you're building it as a database so that you can later on do some kind of prediction. Okay, maybe prediction can reduce cost if you don't have to build, if you don't have to make a sort of like an inaccurate guess as to the demand or something. I don't know. Okay, so it's not quite clear. Now, Incidentally, and this is for everyone, maybe I should write in a comment in the line group. The problem formulation part, okay? There's a question of where does it appear? Well, the problem formulation in a loose sense of the word, like this is going to be a prediction kind of thing, that can appear in the introduction. But the proper, like technical definition, you're trying to predict y as a function of x and y is a scalar and so forth, that appears in the methodology. Okay, that appears in the methodology part of your writing. Okay, come. Very good. So who's next, huh?
So it's me, okay. So let me share screen. Okay.
Make sure I have the right. We must be Thanakorn.
Yes,ครับ
Put chat.
นภาพฤกษชาติครับ
Put chat ครับ Okay, very good.
เห็นหน้าจอใช่ไหมครับ
So today I will present about my big data analytics project, which is about heart disease prediction. And my name is Thanakorn Napapruchat. So about my data set, my data is about the information of heart disease patients. The data is called heart disease UCI, and I got it from kaggle.com. So my data set contains 304 rows and 14 columns, which include age, sex, chest pain type, resting blood pressures, serum cholesterol, fasting blood sugar, resting electrocardiographic, maximum heart rate, exercise-induced, ST depression-induced, the slope of the peak exercise, number of major vessels, and for number 13 is the one that tells us which type of heart disease the patient has. And number 14 is the target, which tells us who has a heart disease or does not have. Now my introduction. Heart disease is one of the most common diseases which can be seen in many people around the world. So I picked this topic because I want to warn people about the danger of this disease so the audience can be well aware of it. And the lower part is why it is so important to be well aware of this heart disease. So my objectives. The purpose of this analysis is to visualize the data and predict the risk of having heart disease by comparing data sets to each other and to predict the possible risk of having heart disease. So I use Google Colab and Mathematica for my dataset analysis. And methodology. For my visualization, I create graphs to display the dataset. And for my supervised learning, I do the prediction analysis by using careful validation and result in confusion matrix. And for my first part of the visualization, I use this to describe my data to see the information such as mean of each information and the unit count, for example. And for here, the left one is the visualization of the statistic of each column. And since it's, some of the column has a really high value, which is pretty hard to see here. So I adjust the graph to show only the information of the column which has less than a value of 5. As you can see on the right side. And next, this graph represents the statistic of age, blood pressure, cholesterol level, maximum heart rate, ST depression induced, and number of major vessels compared to between people who have heart disease and doesn't have. So for example, on this one, it represents which age has the highest rate of heart disease on the data set. And next, this graph represents the peak of each value. Like for the first one here, the most people in this data set that have heart disease are at the age group of 50 to 60 years old, as you can see here. And next, the pie chart represents the gender distribution of the whole data set and the patients who have heart disease. And on the right one is show the distribution of genders, and on the right side, the patient who actually have heart disease. And the lower one is the pie chart represents the distribution of patient by gender and who has heart disease does not have. On the right hand side, the bar graph represents the number of people who have heart disease by gender. Like this one is the number and this one is the distribution of percentage. Now this graph represents the heart rate and age of each people with disease and without disease. And this graph represents the heart disease frequency of each age group. And these graphs represent the maximum heart rate, resting blood pressures, and serum cholesterol. And this part is from Mathematica. This one represents the maximum heart rate distributed by gender. Like this is the count of number of the patient on the list. Like the female here has around 140 and male has more than 200. And here's a stat of the heart rate between each patient. And this graph represents the blood pressure level distributed by gender. And for this one, it represents the maximum heart rate between people who have heart disease and does not have. So now it's come to my supervised learning. This diagram represents the prediction of the risk of people having heart disease and does not have. And I use case for validation, which will split my data into 5 parts to test and train. And the result is shown in confusion matrix. And for the top one, it is a SVC model, which is a non-parametric clustering algorithm, which the objective is to create the best fit to fit the data that provide. And the lower one is random forest classifier, which is a classification algorithm that consists of a decision tree, and it will create a forest of many decision trees to make the prediction. And here is the accuracy of each model. And this shows that the SVC model has a bit more accuracy than the random forest classifier. And here is my mind map. And that's it for today. Thank you.
Okay, I think your slides say that a confusion matrix plot is a methodology. I think you have to correct that. It's just representing it's a method for presenting the result, not the methodology for prediction. I think it's a typo or something. Okay, I didn't go over this kind of visualization, but it's a good time to show you. Let me share my screen. This is called a violin plot. I think it might be for your project. I think you did a very good individual factors histogram. What you should add, perhaps, would be again the interaction between any pair of them. So scatter plot, like a pairwise correlation plot, that would help. Another thing that might help, because you're focusing, I guess, on different population, age, and sex. Maybe you can do a violin plot as well. A violin plot I haven't said before in the class, but let me just show you a picture of it real quick. It's this guy, well, you can imagine it looks a little bit like a violin. So you can imagine that you can say this is an age from young to old. Maybe there's some other example. I'm trying to, yeah, something like this. Usually you see a lot of demographic chart presented as a violin plot. Okay, so you have something like maybe this is men on the left, women on the right, and this is the age group. So maybe there's something like this for normal people without the disease, and there's one for overlaying with the disease. You can see that you can see that this one has 2 lines to it. So that might be, yeah, that might be helpful. Something like this. Okay, there it is. Okay, and this is sort of like what I mean. So you can have actually a male versus female, age, young to old, and then the distribution of disease versus not disease, that kind of thing. I think that might be helpful in your thing as well. Okay, now we go with
ประพัฒชนครับ
ประพัฒชน, yeah. Okay, good. You're up. Okay,
Can you I'll share the screen. Can you guys hear?
Hi everyone. My name is Papachun Kentong, and
Can you guys hear? Okay,ครับ.
Yes, we can. Okay.
From the ISE, the project that I decided to go with for the big data subject is about the pH of the bottled water. So behind me is my factory in Nakhon Pathom, Thailand. So the reason that I picked this topic, because it's directly related to my family's business. Lately, the pH of the water that we've produced are very varying. So I'm trying my best just to know the reason behind it. And the first thing that came to my mind is the weather. The question that I want to answer is which kinds of weather factors that contribute the most to the pH of the distributed water. And also, I want to see if I could use the linear regression to find a legitimate model by using the big data that I have gathered from the lab inside there of the factory that we use to monitor our pH and all sorts of stuff, along with the data that I have acquired from the Thai National Weather Department. So without further ado, let's go see the process that I use. So the first data set I have gathered is from the Thai Meteorological Department, which requires me to send the email to the department and gather all these data sets. This is the data that I have gathered from the Thai Meteorological Department, and this one is from my factory. And for the data wrangling process, my factory lab closes on every Sunday. So I couldn't use the data set that I have gathered from the Thai Meteorological Department on Sunday. So I have to manually cut them. And this is the final data set that I have gathered. So in total, it consists of 7 columns and 136 rows in total. After acquiring all the data set, I input the data set into the IBM SPSS statistic program to find using analyze, regression, and linear. So these are all 5 independent variables that we are going to take a look at. Here are the results. So there are 2 models that they are used. So the first model is the lowest temp and TDS. Now let's take a look at the R square of the 2 models. So as you can see, the R square of the 2 models are pretty low. So what it essentially means is that these 2 models can only predict by 33% to the 36% of the pH, which is considerably quite low comparing to other types of models. But the significance is quite high. So it means that these models can be used, but just to estimate around 33% to 36%. So if I have to choose, I would definitely go with the second model, as the R square of the second model is higher than the first model. Here comes a $1 million question. How do I decide that it is actually linear regression, or should linear regression be good for this particular topic? So it has something to do with a little thing called VIF. Now, let's take a look at the VIF. VIF, or the collinearity statistics, say or state whether this particular set of data can be determined or can be analyzed via linear regression. So for this model is 1 and 1.009, which is acceptable for most cases of linear regression analysis. So in conclusion, the weather factors that contributes the most to the pH of the water is lowest temperature and the TDS, or total dissolved solids, of the water. Although the prediction model is not as good as I expected it to be, I totally believe that this project will lead me into the further findings of the pH of the water. Thank you.
Okay, Kap. I think this project has quite a lot of upside. I think if you had another month on it, it would be a very good project. I think on the analysis side, on the model building side, it's a little bit it's underdeveloped at the moment. Okay, the use of BIF to analyze, whether or not your problems suffer from multicollinearity, I think that's good. That's good. You can flesh that out. Having said that, there's no stopping you from using any other kind of prediction models. Okay. Again, regression is still the mainstay of, say, econometrics analysis. Part of it is because of tradition. Part of it is the way government white papers are written, in a very standard format. Y is a coefficient, and you have to keep the coefficient and all that. So they tend to be stuck to that linear regression need. Okay, and you have to do all kind of justification, whether or not it has multicollinearity, and if it doesn't, then you can go on and so forth. We're not in that world right now. We have a lot of supervised learning tools at our disposal. Okay. In fact, and this is a general comment. This is a general comment to everyone. The data science is an experiment. Okay, science is a theory backed up by evidence. Okay, in data science, the experiment is a combination of the set of data and the set of methodology, right? So what a lot of you have done is to be very single-minded about methodology. Okay, now yours in this case happen to say, I'm going to stick with linear regression. A girl 2 presentation ago say, I'm going to stick with support vector machine. There's no need to do that nowadays. Okay, there's no need to do that nowadays. There's good case for preferring one to the other when it comes to model explanation in terms of explaining the coefficient. Like I said, the rule of thumb is go for the one that gives you the best predictive performance. But if they are of the same or similar predictive performance, go for the one that's easier to explain. Okay, but that means that in my project or in my line of work, I don't start out with a single allegiance. Maybe that's the word I should use. You should not have an allegiance to a method. Okay, you should be completely method agnostic. Okay, just try this, try that, whatever works. In fact, I'm doing a project now in my consultancy work that requires a total of, I think, 25 different model settings. Okay, not the data setting, but different configuration of the models, just to see which one works. All right. So don't have allegiance to linear regression. Don't have allegiance to neural network. Don't have allegiance to support vector machine. Don't have allegiance to any method. Right. They are all candidates for experimentation. Okay, so I think I think you were probably spending a lot of time on the data sourcing, so I sympathize with that. But also, I think when you were recording the video, you forgot to turn off the music in the background, so it kind of kept playing. Okay, so again, this has a very high good potential to be something very, very interesting. Okay, right now you just maybe you needed a little bit of work on the analysis. Not quite sure what model you use there, because you jump immediately to if you're going to talk linear regression, at least show us the regression equation and the coefficient values that you ended up with. Okay, and also and you don't need to do any standardization per se, because with linear regression it takes care of that. Okay, so next up, please, Kap.
สวัสดีครับ it's me ครับชวิตครับ let me share my screen is it on ครับ
Yes, it is.
Chavis Panjinda, and for my final project in big data analytics.
Sorry. I think maybe you have to share the screen with your browser. I cannot see your browser. Or maybe your video.
sorry ครับ wrong screen ครับ
Don't worry. Okay, cool.
is
Now
it
I
on the
can
right
see
one
it. Yes, the right one.
okay thank you class I'll be doing FIFA 22 analytics. There'll be three main topics in this slide. First is creating a team consists of many type of player. Second is comparison of each statistic variable. And thirdly is creating a linear regression model to compare the overall stats to the other stats. So first, let's get started with the dataset. So I use the dataset from sofifa.com, which I found this website from Kaggle that one of the user in Kaggle refer this website as their source of data. So I use this one instead. And my data contain 115 columns and over 11,000 rows of data. So first, the top used information in football. I created the first common use one is 433, and this one I create a variable which is the best overall that the team could be. So for each position that I'll find the best overall that position could get. So the process I did is first I look at the data through roughly, and then the problem is that the position of the player are two very detailed position. So what I do is I create a class where it will group the player formation such as center back, left center back, right center back, and others just into defenders, and then grouping the midfield into one big classes. After that, I sort the player by their overall, and I'll pick the first one in each position to be in the team. And for this one, which is the best potential, you can see that the player have changed because with changing the sorting to the best potential, player have changed their ratings. And this one has two variable, which is youngest Premier League player. So the first variable is youngest, and the second one is only in the Premier League. So what I did is from all the player, I filtered only Premier League player, and then I create a simple position like I did with other data. And then after that, I sort the player by age and date of birth, and then pick the one that is the youngest for each position. And for the second topic is the relationship between two statistics of all players. So this is all the statistics compared to each other. We can clearly see that there's some correlation, which is darker color around the normal statistic that's not including the goalkeeping skills. And we can also see the one in the overall and the potential different. And this is also another stat compared to each other. The first one we can see clearly is that left foot player will be black and the right foot player will be red. We can see clearly that most players in the game are right-footed. We can see some weird correlation between overall and potential, that there are one line straight that no player crosses. And the statistic between acceleration, speed, and agility tend to go as a linear regression, as a linear graph instead of other where it's all over the place. And this is visualization of comparing overall score to the age of player on different foot. So I want to see that does age have any effect on the overall scores. And what we can see is that in the player age of around 20 to 30, they tend to be in the overall around 60 to 80. But then when they are younger, their overalls are lower. And this one is comparing the age and potential and the value of the player. I want to know if does age also have any different effect on potential and the value of the player. So on this graph, we can clearly see that what have effect we can see clearly is the value of the player, that the higher the potential, the higher the value of each player would be, but we cannot see the trend between potential and age clear yet. So what I did is I subtract the overall rating with the potential and see the difference of the potential and the overall rating. What we can see is that the younger the age, there are more difference between potential and overall of the player, which means that the player can be improved much more when they are younger, instead of if they get older, their overall and potential are nearly almost the same. And this one is comparing dribbling and crossing to each other. What we can see is that it is like a linear one where there are two clusters of player around 2 points. And this one is comparing age to the pace of the player. So if you see that does the speed of the player have, the age of the player have any effect on the speed? So we can see that the average top pace that the player could get will be at around age of 25, and then it tends to decrease within the age of the player. And for the third topic is the linear regression of the overall statistic of the player. So what I did is splitting the data, taking the overall and then split it to 10 test data. And I do the permutation too. And what I saw is that the permutation is that the most important one is the potential and age, which have the most effect to the overall rating of the player. And this is the result of the model that I got. The accuracy of my model is 93 accurate to the actual overall rating. So this is comparing overall to the predicted overall. So the overall is like what the overall actually is and what the model has predicted out, and it's 93% accurate, which is very good, I think. And for my future project, what I wanted to do is using decision tree to tell the position of the player by their skill and their statistic. I have seen some people on the internet do like decision tree to just tell that if this player is good at dribbling, there should be midfielder or a forward player. Thank you.
Okay, Cup. Very good. I think wasn't quite clear in the beginning what you mean by the statistic potential. Is that something that is actually a determined statistic, or is it something that you want to use as your target? It's because at some point it looks like it is a target. You want to determine the potential of player as a function of age or whatever, left-footedness, and then later on it becomes an input to the prediction of the value. So
like on like this kind of thing, like the start,
first of all, where are the numbers of the potential? This you get it from like a rating or something?
Yes, it's from like the FIFA online game. It's like a PlayStation game where
so there's a value for potential, right? There's a value for potential.
Yes, they have like every statistic, like overall potential, stats, value, and
good.
everything.
I see what you mean. Okay, and this is what this is. For example, what is this correlation that you mentioned? It's very interesting between, say, third row and second column.
This one.
What's the third row? What's the third row? I can't read because it's too small.
The third row is potential. So
potential. And what's the second column?
Second column is overall, like the overall rating compared to the potential of the player.
Oh, okay. So, and what's the third column?
The third column is the potential comparing. Third column is potential.
Second and third are both potential?
So second row and second column are overall, and third column and third row are potential. So like this one for this graph is like once the overall is within this line, there are no players that have like lower potential than the overall.
Okay. I think this is the one comment I should like to make is similar to one or two projects from the previous session last Tuesday, in that you have to make sure what is your target. If your target is an index, make sure that it's actually not including the explanatory variable. So if the value, for example, includes the potential, or if the potential is defined partially by some statistics that also define the value, the fact that you have a very high predictive ability is not meaningful. You see what I mean? So if you have y as a function of x and you get like 95% accuracy, but it turns out that both y and x are partially defined by some common thing, like maybe scoring percentage or whatever, I don't know. Okay. So make sure that that is not the case. That's not the case. Okay. If that were the case, then the accuracy is self-fulfilling, right? is self-fulfilling. Y is accurately predicted by X, but both Y and X are actually the component that has a component, has common component, okay? In which case it's self-fulfilling, okay? But having said that, I think the idea that you turn kind of scoring into individual games planning, that's quite interesting. What about the positioning, the 4-4-2 or whatever? That is not part of the analysis, right? That is just
that's just like kind of like me playing with the data of like I want to try out like can I do this or do
that. There isn't anything like this guy being a left footer should be in the right side of the field or left side of the
I haven't done like that much because it's like for the formation I think it's not really important. It's just like me testing out that can I do like with Python can I do like sorting the data throwing this filter or something like that.
That's good. Okay, like, I think this is very good. I think you at the experimental stage. If you want to sort of make something really significant out of it, I think the part you mentioned in the future work, sort of like decision tree, if this person has this characteristic, something like that can be very, very important. So I can imagine this is something that would say help in planning your roster at the player time, okay? And of course, there was actually a project from last year's class that touches on a little bit like this, I think like in basketball or something. But in which case, it's something like not only do you plan your players based on strength, you plan your players roster based on the opposing team's strength, right?
So
each individual match, you know who you're going to play with, and you could sort of guess what's their roster going to be, and then what's your best counter strategy. Okay, so it's very interesting. I think sports is one of those simulation scenario that's very good for testing this kind of analytics. Okay, Kap. Next.
Thank you, Kap.
How are we doing on time?
I think we are a little bit late.
Okay. I'll shorten my comments a little bit next. Okay, Pawaran, right? Pawaran.
Pawaran.
Pawaran, Kap.
Let me share my screen.
Okay.
Good. You upload the YouTube and you're using the right name, and I like that.
Okay. We all know education is one of the most important foundations for human beings. It creates an opportunity for people to follow their dreams and achieve the meaning of life. However, each year, more than 1 million kids leave school without even earning a high school diploma. And the biggest cause for that was the poor performance at school. Therefore, the motivation behind this project is to help students and institutions understand the characteristics that may be responsible for poor performances, and also develop a predictive model to predict students' scores based on different factors so that necessary intervention and support can be provided. To get a better overall picture of the project and its methodology, I'll be walking through this mind map. This data is in the form of tabular data. It can be separated into categorical and numerical data. For descriptive data, it can also be separated into 2 subcategories, which is numerical scale containing attributes such as gender, lunch program, completion of preparation course, and race and ethnicity. And for ordinal scale, it's going to be parental level, highest level of education. For quantitative or numerical data, it's going to be reading score, math score, and writing score. Now, for the data analysis, the system model, what we are trying to achieve here is to gain insight about what factors affect students' performance in exams. If I knew X, what can I say about Y? So in this case, X are different attributes and Y are going to be the average score of the student's performance. So it's going to be numerical data, which in this case, we are going to use regression analysis from supervised machine learning. To optimize the model, we are going to see which attribute most affects student score. For the data analysis pipelines, problem formulation here is students' poor performance is the biggest cause for dropout. And education institutions fail to analyze students' performances and develop appropriate strategies to help students. Available resources are from kaggle.com and also some research papers from researchgate.com. In the data preparation process, I'll be finding the data and sourcing and also storing the data. For descriptive statistic, I'll be using data visualization using scatterplot and histogram. For the model validation, 75% of the data will be used for training and another 25% will be for testing. To evaluate the performance of the model, we will use R-square and mean-square error to measure. The two main techniques that we use in these projects are machine learning and statistical methods. I will be trying different regression techniques on supervised machine learning, such as decision tree, random forest, linear regression, and ridge regression. For statistical methods, I'll be using exploratory data analysis, which can be separated into univariate graphical and multivariate graphical. First, I obtain the data set. This data set is a sheet from Kaggle containing 1,000 students and 8 different attributes, including students' gender, race, parental level of education, lunch, test preparation course, math score, reading score, and writing score. After that, I perform data preparation to see data types and missing values. I did some exploratory data analysis, including the visualization, to find correlations between each attribute. Then I set up regression models and evaluated performance. From the data visualization, it can be inferred that in general, female students perform better on exam than male students. And students who complete the preparation course usually perform better for all gender. Finally, the higher the level of parent education, the more likely the student is to score higher on exam. Now let's take a look at a predictive model that was built using 4 different regression algorithms, including random forest, decision tree, linear, and ridge. By evaluating using R-square and mean-square error as metrics, the result has shown that the ridge regression performs the best with the least mean-square error and highest R-square value. From the random forest feature important plot, it can be seen that the data attributes related to the lunch program and test preparation course of the students are among the factors influencing most of the regression process. The result from this study are the initial steps to develop useful strategies to improve the education system and learning environment. The conclusions made from this study can be used for defining future steps in the educational data mining project in order to achieve more accurate results and to extract more important knowledge from the data.
Okay, very good presentation. So like trace through the step of the logic. A little bit of niggling comments here and there. Completion of the preparation might not be a nominal scale, although it's binary, so you can say it is. Because after all, you would imagine that somebody who's completed maybe 50% of the preparation or completed 100% of the preparation would be more likely to succeed or whatever. Okay. I think you have got the overall process quite right. At the end of the day, oh, by the way, ridge regression and linear regression, you could just put that under statistical method because it's very classical statistical method, not a machine learning. The idea is this: if you have something that you can write down as an equation, and each individual coefficient means something, okay, that tend to be what traditional statistical model looks like. Okay, with machine learning, then you have some parameters, some coefficient that you can't exactly say, oh, this is the coefficient for how much y changes as a function of x, something like that. You can't do that. So that's that would indicate that the parameter, the method is based on machine learning. So again, machine learning is based on creating a general architecture for learning the data. Okay, it's not imposing this coefficient is, for every 10% increase in lunch budget, you get 5% increase in performance or something like that. You can't interpret it that way. Okay, so I think I'm not quite sure how the results are actually holding up in terms of significance. R square of 0.2 or whatever, it's not exactly reassuring. Okay, so you would not try to sell in the report. You would actually say that check the statistical importance. Now you go ahead, you went ahead and show result for variable importance for like a random forest, which is fine. But since you already have rich regression and traditional linear regression, you can look at individual t-stats. Right. I think I did mention to one project last time that if you are actually if you're using traditional regression model, then you should present the whole result. I don't know if I don't want to waste time looking for it right now, but if you go back to academics, economic research, maybe 30 years ago, every single paper would have equations to say what is your regression equation, and then it would have table of result of all the coefficient, and next to it there'd be like a little star to say whether or not it is statistically significant or not significant at 95%, at 99%. It's very traditional standard. Maybe I'll this evening I'll find very traditional paper. Okay, so economic paper used to be exactly like that. So if you're using a regression model, I would expect you to provide table that looks a little bit like that as well. Okay, but let me not search for it right now to save time and go ahead to the next person.
Thank you,ค่ะ.
But it's a very important problem to tackle. Good.
So next is Nanapasan.
มีค่ะ
Okay.
Can you hear me ค่ะ
Yes, we can.
Okay. So I'm gonna start now. Wait.
Data analytic project about the energy. Good morning, everyone. Today I'm going to present my big data analytic project about the energy expenditure prediction. Here are all of the content. My project is an energy expenditure prediction. The project displays the association among the age, gender, weight, height, duration of workout, heart rate, and the total burned calories per session. This project uses machine learning with Python. Is using Google Colab as a coding platform. According from the study, some wearable device is not always accurately measure the calories. So the objective of this project is to study and improve the machine learning to be accurately predict the calories expenditure based on heart rate and other personal data gathering from users. Therefore, my project are using data regarding energy and exercise from Kegels. There are two files which contain 107.3 gigabytes in total, including 9 personal data as known as unique values, such as user ID, age, gender, heart rate, and calories. The size of data for the exercise.csv, there are 8 columns and 2 columns for calorie.csv file. Each row represents value gathered from each user. The personal data are their gender, age, height, duration of workout, heart rate, and body temperature.
And here is my mind map. Starting with the demo, for the data processing, we split and test the data using carries.h function to display the first 5 rows as a preview of the carries and exercise.csv files. Containing values are user IDs, carries, gender, age, height, weight, duration, heart rate, and body temperature. The second figure indicates the value that used in prediction. For the first picture here, on the left down side, you can see that there are 50,000 data points, which is each row represent different people with different 9 features here. When we run this, it will give out the important information such as the number of entries, which is the second figure here on the left down side. Below the first one, this display information of the data, missing values, and the total of entries, including the data type of each column. And to check for the missing value by using .isNow.sum function, the number that display the missing value is all 0. This means that there are no missing value here. So because we don't have a now value, so those method to handle with missing value as is not necessary for here. Moving forward to the next step. This is the data analysis section. The statistical data such as a mean, range, percentage are displayed by describe function. As a user ID is not an actual count number, so we will skip them to the other columns. The data show that 50% of people in the dataset are approximately at 39 years old, which is quite near the mean value, which is 42. The duration of exercise is also shown in the column as well as heart rate, body temperature, and calories, which is the mean, maximum, and minimum are also shown in here in the rows. To visualize the data, using SNS.z to run out this simple plot, such as count plot, which is shown in the left-hand side, distribute and display the male and female count, and this plot, which are shown on the right-hand side here, visualizing age, weight, and height. In addition, the male and female is not well distributed as it is really similar in size. So we use this plot to distribute those columns for better visualization. The x-axis is named as a density, represent how much of data being processed, and there is a peak of each plot, represent the highest point. Next is the correlation C bar that I set the size at 10. This is a heat map that represents the value based on the value ranging from 0 to 1, which one is the highest and 0 is the lowest value. The value will be calculated by the relationship between the data. Each column will be compared to another. If they're getting close to 1, the darker shade of the blue it means that they are more positively correlated. By contrast, the more it's getting close to 0, the lighter of color is they are negatively correlated. From the diagram, height and weight is the pair with the most positive correlated to each other, following by exercise duration and calories. Now, moving forward to the step of converting the text data to numerical value using the replace function. This will replace male and female as 0 and 1. Next is a separating step that will drop some columns off to separate features from target. So I chose to separate user ID and calories from the other column. Then we are splitting them into 2 types of data, which are training data and test data, by creating 4 arrays, which will represent different X and Y training data and text data. The data will split it based on X and Y. Then the split data is printed in shape by .shape function. For the model training, using model.fit function with XT regression so that we can evaluate the model. Now we are moving forward to the evaluation part. The model evaluation is done based on test data. The predict function have been used to predict the Y test value. Then comparing the outcome and the carries data by using mean absolute value. For this model, the mean absolute is 2.7.
That's it ค่ะ
By the way, I think most of you started with looking at histogram of individual data field. Okay, let me just make a quick suggestion. For any kind of analysis where you actually have a big category like male versus female, you might as well pack that information in. For example, if you look at your I think there was a histogram that has to do with the weight. Instead of having a unimodal distribution, it has two hump. My guess is the reason you have two hump is because you're combining male and female. Okay, so in that case, in one histogram, instead of having just the weight distribution, just make two lines, one for male, one for female, and that would clarify things up a little bit. Okay, so you in the beginning of all the project, yeah, I would certainly look at histogram of individual factor. But once you get to presentation, you pack in additional information, and male and female is a very easy big category to separate. Okay, so you can do that for every histogram. So you just do histogram of height, of energy, or whatever. Okay. In terms of prediction, okay, I'm not quite sure how strong the results are. You have to show a little bit of the root mean square error of your calorie expenditure prediction. So focus a little bit on that. Other than that, okay, it's all right. Okay, come. You didn't mention anything about partitioning your data into training and validation and testing set. Did you do that did you do that? Okay, just make sure you don't skip that. Okay, you're not trying to overfit anything, but again, if you don't tell me a specific step, like what is your in sample, out sample proportion, I can only guess that you have done it. No. Okay, just be a little bit more precise in your write-up. Okay, come next person should be
ทอขวัญค่ะ
ต่อขวัญ
ทอขวัญค่ะ
ต่อขวัญค่ะ okay, you're up. Okay, come, very good.
โอเคค่ะ
I can see your forehead. Okay, I can see your nose. Okay, go.
โอเค Hello everyone, I'm Thawkwan Isaac Desha, a second-year student from Mahachai Chulalongkorn University. As I have been learning big data analytics at Mahachai, I'd like to share with you my final project, air conditioner energy use comparison. This project is based on Mathematica and the data is from Kaggle. For the project inspiration, as air conditioner is the biggest energy usage in the house, it is better if you can compare energy usage with other similar houses, which provide you the opportunity to improving your electricity usage and saving your cost. The data for this project is a household monthly energy bill data of households in India. The data size is 1,000 rows and 9 columns. The target data are column 3, 4, and 9, which are house area, air conditioner, and monthly amount paid. First of all, I did data cleaning to focus only the target data. As you can see, I imported the data and divided data into two sets, training data and testing data. After removing not targeted data, there are 376 rows and 3 columns left. Then I create a data table and set a new header for both rows and columns. Secondly, I did a data clustering to identify and group the data. Clustering is one of the most widely used techniques. I use spectral method since it reduces complex multi-dimensional data sets into clusters of similar data in layer dimensions. Then I did data visualizing by using list plot to see how the data group. For the methodology, I perform cluster analysis with unsupervised learning by separating the data into 3 groups, which are more energy efficient, typical, and less energy efficient. Then I perform data classification with supervised learning. I training the program by using classify function. The output is a classifier function, and when we put some input to the function, it will label the result. For the experiment, I use a training data set where the output are not accurate to the clustering data before. And for the result, I use a testing data set to compare the result. Some output are reasonable to be in the most likely cases, but some still not accurate. For finding an insight, there is other factors. Comparing the energy usage, there are other factors that need to be taken into account like local weather, electricity charge during day or night, and more. For the limitation, the data is limited. There are no public data about air conditioner usage with the house sizes. For future improvement, since there is a limited data, the input for the program training is also limited. In the future, I can improve this project by collect more data with various factors. And here is my overview project mapping. Consists of 3 subtopics, which are project overview, data set, and working process. And it is the end of my presentation. Thank you for your attention.
Okay, Kap. So you did dimensionality reduction to come up with the 3 cluster, correct?
Yes.
Okay. You weren't quite clear on what method you used to do the dimensionality reduction. Now, because you were using a Mathematica sort of like decorative thing, you want to do dimensionality reduction, you want to do classification. You just give a generic, give me a classifier, give me a predictor, and Mathematica, because this is a small data set, it's just going to try a few combinations. Now, if you notice, once you get the result as a model, there's a little plus sign that you can click, and it's going to give you the description of what the model is. So, just because you use a very easy built-in decorative command, find me a classifier, find me a predictor. When Mathematica found those, it's going to tell you as well what method it used, right? So in this case, prediction may be the best predicted model that it thought suits the data is decision tree. Then you have to report that methodology, right? So it's not this is the opposite of your friend. Some of your friends have in mind, say, I want to use support vector machine. I want to use linear regression. With you, you just want to try anything. Just have Mathematica suggest. Well, that's fine. That's okay. That's valid. And at the level of user that a lot of you are, I think that's completely valid. But once you get that, you have to make a mental note or make a logging of what method it was chosen as well, right? Because for different data set, it may choose a different method. So you have to know that, okay? Don't just say, I threw this to the dimensionality reduction and I got that. Because there are many different dimensionality reduction algorithms, there are many predictor algorithms, okay? So once you get the result, you click into the model description, it's going to give you information. You have to put that in as part of your report as well, okay? Okay, very good. Other than that, it's not quite clear, for example, how the good or very good the result that is, in terms of classification. So you have to show, I think you have more than one class, right? So you have to show ROC and the confusion matrix or something. Yeah. So I don't see it yet, but I'm sure it's going to be in there in the final report. Okay, next up.
Next, Mila. Mila, are you here? Okay.
Hello, my name is Mira Angelin. This is my big data project presentation. Among various life-threatening diseases, heart disease has generated a great deal of attention in medical research. The diagnosis of heart disease is a challenging task which can offer automated prediction about the heart condition of patient so that further treatment can be made effective. The diagnosis of heart disease is usually based on signs, symptoms, and physical examination of the patient. There are several factors that increase the risk of heart disease, such as smoking habit, body cholesterol level, family history of heart disease, obesity, high blood pressure, and lack of physical exercise. This project will predict the heart disease of people with 13 attribute informations with supervised learning process. However, the name and social security number of the patient were recently removed from the database and replaced with dummy value. This is the heart disease UCI dataset from Kaggle with 14 columns and 303 rows. When we look into this dataset, the 14 column will include age in year, sexes, 1 for male and 0 for female, chest pain type, which has full value, raising blood pressure, millimeter of mercury, serum cholesterol and milligram per deciliter, fasting blood sugar less than 120 milligram per deciliter, resting electrocardiographic result, maximum heart rate achieved, exercise included angina, ST depression included by exercise relative to race, the slope of the peak exercise XT segment, number of the major vessel covered by fluoroscopy, tau, 3 for normal, 6 for fixed defect, 7 for reversible defect, and the target. 0 is no risking, and 1 is risking of heart disease. This is the statistic of the data, showing all count in each column, mean, standard deviation, minimum and maximum in each attribute. From this graph, majority ages of people in this dataset is about 50 to 60 years old. The resting blood pressure is about 120 to 140. The maximum heart rate achieved is 140 to 160, and the ST depression is mostly 0 to 1.5. The target column will show the people who had heart disease, 1 for defective heart and 0 for normal heart. Therefore, in this dataset, 165 people have defective heart and 138 have normal heart. Splitting data process will separate the target column, which is telling the heart disease, out of other column, and set it as a Y value. The accuracy from the tasting data is around 80% from the sklearn metric library. To predict the heart disease, user need to put all the 13 attributes that I have mentioned before, and the program will predict the user risk. From the confusion metric, majority of the prediction is matched. Only 11 out of 61 is unmatched. And this is the mind map, which will summary all the process of this project. Thank you.
Okay, similar problem. Is this the same data set as used by Kanakon? Is it the same set or no?
Yes, it's the same data set.
Okay, that's the same data set. And how? So just check that. I guess you might want to look at each other's results and discuss a little bit and how you're getting the difference or not the difference. I'm not sure about some. There's one. I think one variable that has a encoding of 3. That is said 3. The maximum is 7. I'm not sure what that value is. Is that something that should be one hot encoded or not? Okay. I think when I get the report, I can sort of look at both of your paper and see what that is. Also, you have a little typo. One does not risking. I think that's grammatically incorrect. So I think there's a typo there. One does not have high risk, or one does not register high risk or something like that. But one does not risking. I think it's grammatically incorrect. So I think it's a typo. Okay, so let's I'll take a look at both of your paper. I guess. Okay, let's take a 2-minute break so that, well, actually this video break so that we can chop this video up into 2 halves and come back with polls at home.
Okay,ครับ